Hello everybody, welcome into another lesson. So today we are going to do the final part of factoring by grouping. And we start out here with a difference of two squares. Only the second square is a polynomial. Whenever you have that, let me show you the simplest way you can do this. You can use a let u equal y minus z. So I would let u equal y minus z and perform a u substitution. So what you'll get is x squared minus u squared. And now we have something that's much easier to work with for factoring. Factoring the difference of two squares, you'll get x plus u times the quantity of x minus u. Now, of course, we have to substitute whatever u was back in for where u goes to get the original equation. So when we do that, you'll get x plus whatever u was y minus z, so you get x plus y minus z, that quantity, times x minus y minus z, which we can simplify the second factor. We'll still have x plus y minus z, that quantity times the quantity of x minus y plus z. So the factorization you should get for this would be the quantity of x plus y minus z times the quantity of x minus y plus z. So sometimes doing a u substitution can make your life a lot easier. Alright. Let's see, we got a plus 2b, that quantity squared, minus 9c squared. So we have a difference of two squares. The only thing is the first term's a polynomial. So what you should do is a u substitution. Let u equal that a plus 2b. U will equal a plus 2b. What you'll get next is u squared minus 9c squared. That's much easier to work with as far as doing a difference of two squares. So then to do that, of course, you'll get u plus 3c times u minus 3c. And then now you just put whatever that value for u was back in where u goes to get the original. U is equal to a plus 2b, so you'll get a plus 2b plus 3c, that quantity times a plus 2b minus 3c. So the answer you should get for this factorization would be a plus 2b plus 3c times the quantity of a plus 2b minus 3c. You don't have to use u substitution. You can factor it right out, but I think personally learning this, it's going to be a lot easier if you do a u substitution. Alright, let's see. We have u minus 2v squared. That quantity squared minus 4w squared. Well, this one has the variable u, so I don't know. Let's perform an x substitution. We'll let x equal u minus 2v. Basically, just pick another variable and substitute the u minus 2v. I'm going to say let x equal u minus 2v, so what you'll get now is x squared minus 4w squared. That makes your difference of two squares much easier to work with. So when we factor this, you'll get x plus 2w times the quantity of x minus 2w. And now all we have to do is substitute the value of x back in to get a form of the original equation. X was equal to u minus 2v. So that'd be u minus 2v plus 2w. That quantity times the quantity of u minus 2v minus 2w. So your factorization of this should be u minus 2v plus 2w, that quantity, times u minus 2v minus 2w. So, yeah, using the u substitution method, or just the substitution method if you want to call it that, it's going to make your life so much easier. Alright, what do we got here? 4p to the second minus, we have the quantity of q minus 2r to the second. Alright, so we got 4p to the second minus the quantity of q minus 2r to the second. Well, I would let u equal that q minus 2r. I would go ahead and do that. So then what you're going to have now, you'll have 4p to the second minus u to the second. And that's so much easier to work with when you have a difference of two squares. So to factor this difference of two squares, of 4p squared minus u squared, you would get 2p plus u times the quantity of 2p minus u. Now you just put the value for u back in wherever you see the u. You would get the quantity of 2p plus q minus 2r times the quantity of 2p minus, now we're going to minus the q minus 2r. So this will simplify further into the quantity of 2p plus q minus 2r times the quantity of 2p minus q plus 2r. So the factorization for this should be 2p plus q minus 2r, that quantity, times 2p minus q plus 2r. Alright, let's move into some different problems here. Let's see, what about if we had a plus 2b, that quantity to the second, minus 2b plus c, that quantity to the second. Well, what you're going to want to do, you're going to want to do a couple substitutions. I would let u equal a plus 2b, then I would let v equal 2b plus c. Okay? So if you do that, u equals a plus 2b, you'll get u squared minus that 2b plus c, that's v, so you get u squared minus v squared. Much easier to work with. Now, to find the factor of the difference of squares, you of course would take u plus v times the quantity of u minus v. Okay? So what you're going to have to do now, put in your values of u and v where they go. U is equal to a plus 2b plus your v, which was 2b plus c. That quantity times, you got u was a plus 2b minus your quantity of 2b plus c. Now you simplify each of the factors, you would get a plus 4b plus c times the quantity of a, 2b minus 2b, the b's are gone, you just have a minus c. So the factors of this expression would be the quantity of a plus 4b plus c times the quantity of a minus c. So yes, use a couple substitutions if you need to. That's what I would suggest doing. Use a couple substitutions if you need to. Alright, what we got here? 4 times x plus y, that quantity squared, minus the quantity of 2y minus z, that quantity squared. So once again, I would set up a couple substitutions. I would let u equal the x plus y. U is going to equal x plus y. We'll let v equal 2y minus z. Okay? What you'll do now is you'll put in x, where x plus y goes, you'll put in u. You would get 4u to the second minus that 2y minus z, that would be v squared. So you get something much simpler to work with, the 4u squared minus v squared. Now the difference of two squares, let's factor this. You would get 2u plus v times the quantity of 2u minus v. Okay? So now we got to stick back in those values of u and v where they go. So I'm going to make a bracket because we're going to have parentheses here. You'll take 2 times your u value, which was x plus y, plus your v, which was 2y minus z. Take that times the quantity of 2 times your x plus y, that was your u, minus your v, which was 2y minus z. Yes, this can get quite long. Okay. So now we just need to simplify this. We distribute the 2, you get 2x plus 2y plus 2y minus z. That quantity, distribute the 2 here, you'll get 2x plus 2y. Then you have minus 2y minus z, that's plus z. So let's simplify this one more time. You would get the quantity of 2x. Now plus 2y, that'd be plus 4y minus z. That quantity times, then you got 2x here. Then you have positive 2y minus 2y. The y's are gone. Then you just have plus z. So the factorization of this equation would be the quantity of 2x plus 4y minus z times the quantity of 2x plus z. That's exactly what you would get. Alright, we have a squared plus 4a plus 4 minus b squared. Alright, so this is a little bit different here. Let's just stop a minute. We have a squared plus 4a plus 4 minus b squared. Look for anything at all that is related, okay? These type can get a bit tricky. Well, let's just forget about the negative b squared for a second, okay? Look at a squared plus 4a plus 4. Okay, is a squared, okay? That's a perfect square. The square root of that is a, right? 4 for your third term, that's a perfect square because the square root of that is 2, right? If you take 2 times a, you get 2a, and take that times 2, you get 4a. So in other words, what you really have here is a binomial squared. A squared plus 4a plus 4, that'll factor into a plus 2 squared. Then if you expand this out, you would get a squared plus 4a plus 4. You end up with a plus b to the second. I mean, a plus 2, that quantity to the second, minus b squared. Now what you have are a difference of 2 squares. You got something much easier to work with here. If you can recognize, because now we're to the point where we're reviewing all the types of factoring we've done at this point. So if you're able to pick out a binomial square from a trinomial, if you could pick out the binomial square, you're going to be in good shape. You have a plus 2 to the second minus b squared. We can let u equal a plus 2. That's what I would do. We do another u substitution. A plus 2 is u. You would get u to the second minus b squared. Much easier to work with, right? So let's go ahead and factor this out. You would get u plus b times the quantity of u minus b, which now we put the value of u back in, which is a plus 2. You would get a plus 2 plus b times the quantity of a plus 2 minus b. And that would really be it for your factorization. You get the quantity of a plus 2 plus b times the quantity of a plus 2 minus b. Alright, let's see. We got x squared minus 2xy plus y squared minus 4. Alright. So looking at this, it's a similar problem to the last one. You got x squared minus 2xy plus y squared minus 4. X squared, is that a perfect square? Yes. The square root of that is x. Now you got y squared, okay? Well, you can have positive and negative y. If you do negative y to the second power, you also get positive y squared. Now, if you take x times negative y, you get negative xy. Multiply that by 2, you get negative 2xy. So in other words, this is another binomial square. You have x minus y squared for the first part, then minus 4. So if you can recognize how to check for a binomial square, it's going to make your life so much easier. Alright, so now you have x minus y, that quantity squared minus 4. Again, I'm going to say do yourself a favor, let u equal x minus y. So if u is x minus y, you're now down to u squared minus 4. Much easier to work with. The factorization of this difference of squares, you would get u plus 2 times the quantity of u minus 2. Now we just put the value of u back in, which would be x minus y. You would get x minus y plus 2, that quantity times x minus y minus 2. And that would really be your answer for this. Would be the quantity of x minus y plus 2 times the quantity of x minus y minus 2. We got u squared minus v squared plus 2v minus 1, okay? So u squared minus v squared plus 2v minus 1. This looks like a similar problem, only it's going backwards, okay? Humor me for a second. So you're going to have u squared. Now distribute out your negative. Take your negative 1 out. Factor out a negative 1. If you do that, to get negative v squared, you would have to have a positive v squared. You'd have v squared. Negative 1 times what equals positive 2v? That'd be negative 2v. Negative 1 times what equals negative 1? That'd be positive 1. Right, and if you distribute that negative out, you're back to the original. You would get minus v squared plus 2v minus 1. Well, it looks like v squared minus 2v plus 1 is yet another binomial square, because square root of v squared, that's v of course. Square root of 1, you also get negative 1 for a square root. Negative 1 to the second is positive 1. So let's deal with the u squared minus, so you got v, you have negative 1, and if you take 2 times v times negative 1, you get negative 2v, so it is a binomial square. So now you have u squared minus v minus 1 squared. Oh, let's let y equal v minus 1. We'll let y equal v minus 1. So we'll work with something much simpler here for a second. You'll have u squared minus y squared. Much easier to work with. So to factor this, you would get u plus y times the quantity of u minus y. Now we got to substitute the value of y in where each of these go. So you would get u plus v minus 1 times the quantity of u minus the quantity of v minus 1, which we simplify this further, you get u plus v minus 1, that quantity times u minus v plus 1. So the factorization of this is going to be the quantity of u plus v minus 1 times the quantity of u minus v plus 1. Alright, what's next? M squared minus n squared minus 2m plus 1. Well, it looks to be that we're going to have to rearrange some of this here, because we have variables out of order that just don't seem related. They just don't seem related here. you can use the commutative property of addition to do so. We are able to do that. If I were you, I would make it m squared, then move that negative 2m next to that, m squared minus 2m plus 1, then minus the n squared. By the commutative property of addition, you can rearrange these. Sometimes you have to decipher and pick up on which way you need to do it. Now, having done that, it looks like we got something we can work with. We have m squared minus 2m plus 1 minus n squared. Focus on the first three terms only. M squared minus 2m plus 1, it looks like another binomial squared, because the square root of m squared, well, that's just m. Square root of positive 1, it can also be negative 1. Negative 1 can also be one of the square roots of positive 1. How you know if you want to prefer negative over positive is if your middle term is negative. If your middle term is negative, you're going to need to take a negative root of your third term, okay? Now, twice m times negative 1, that's negative 2m. So you do, in fact, have a binomial square. You have m minus 1, that quantity squared, minus n to the second. All right, now if I were you, let u equal m minus 1. So if u equals m minus 1, you now have u squared minus n squared. Much easier to work with. The factorization of that would be u plus n times the quantity of u minus n. Now we just substitute the values of u back in. U is m minus 1, then you have plus n, times the quantity of m minus 1 minus n. And that would be your factorization. Would be the quantity of m minus 1 plus n times the quantity of m minus 1 minus n. So yes, at first it can seem a bit much, but doing the substitutions really do help, though. I have found that. It makes your life so much easier than trying to factor it out right. Because when you factor it out right, sometimes it can become very messy. Alright. H squared minus 4k squared minus 4h plus 4. All right. How are we going to do this? Well, what I would do, you're going to have to use your commutative property of addition again. Use your commutative property of addition. I would take your h squared minus your 4h, move that over, plus your 4, and then move your minus 4k squared to the last term. So now you got h squared minus 4h plus 4 minus 4k squared. Well, let's focus on h squared minus 4h plus 4. Just focus on that a minute. Square root of h, well, that's going to be h. You have a negative sign in the middle, so you're going to want to find a negative root of 4, which would be negative 2. Now if you take 2 times negative 2 times h, you get negative 4h. So this is a binomial square. You now have h minus 2 to the second, that quantity minus 4k squared. Now you got something you can work with. And then I would let u equal h minus 2. Put u in for h minus 2, you get u to the second minus 4k to the second. something much easier to work with, you'll get the quantity for factorization of u plus 2k times the quantity of u minus 2k. Which now, let's put the value of u back in. You would get h minus 2 plus 2k. That quantity times h minus 2 minus 2k. And that would be your answer for your factorization, would be h minus 2 plus 2k, that quantity times h minus 2 minus 2k. I got about 11 more. Got about 11 more problems, then we're done for the day. Sorry if this is a long lesson, but this is very important. A squared minus b squared minus 2a plus 1. So we got a squared minus b squared minus 2a plus 1. Well, again, use your commutative property of addition to rearrange it into something that would be factorable. I would do a squared minus 2a plus your 1, then minus the b squared. That's how I would do it. Now let's just focus on the first three terms. A squared minus 2a plus 1. Square root of a, that's going to be a. Now you have a negative sign for your middle term, so you need to find a negative root of 1, which would be negative 1. Now if you take 2 times a times negative 1, you get negative 2a. So this is another binomial square. You get a minus 1 squared, that quantity minus b squared. Now you got something you can work with. And I would let u equal a minus 1. U will be a minus 1. So u squared is what you would get now, minus b squared. Factor that, you would get u plus b times the quantity of u minus b, which we put the value of u back in, you would get the quantity of a minus 1 plus b times the quantity of a minus 1 minus b. So the factorization of this is a minus 1 plus b times the quantity of a minus 1 minus b. All right, let's see. We got p squared minus q squared plus r squared minus 2pr. Alright, so we got p squared minus q squared plus r squared minus 2pr. Well, you're going to, again, what I'm going to suggest is you're going to want to use your commutative property of addition to rearrange some of these terms. Notice you have a p squared, an r squared, and a minus 2pr. I would arrange those so they're next to each other. The q squared kind of seems to be on its own. So use your commutative property of addition, you'll get p squared minus 2pr plus the r squared, then just minus your q squared. Now this looks a lot like something we can use, as opposed to this mess up here. Look for, if you can spot terms that look lots like a binomial square, that will really help you. So, let's focus on p squared minus 2pr plus r squared. Forget that q squared for a second. Forget all about it. So, Square root of p squared, that's p. Now you have a negative sign for your middle term, so you're going to need a negative root of r squared. Well, that'd be negative r. If you take 2 times p times negative r, you get negative 2pr. This is a binomial square, also known as a perfect square trinomial. You can call it either term, perfect square trinomial or binomial square. You get p minus r squared, then you just have all that minus q squared. Now you got something even more you can work with. So go ahead, let u equal p minus r. P minus r being u, that would be u squared minus q squared. Factor those, you get u plus q times the quantity of u minus q. Now put the value of u back in, you would get p minus r plus q. That quantity times p minus r minus q. And that would be the factorization of this problem, would be the quantity of p minus r plus q times p minus r minus q. All right. 4s squared minus 4t squared plus 4s plus 1. Okay. So, at first glance, this looks like a hot mess of how the heck are we going to factor this. Notice you have an s squared, an s, and a 1 term. I would try to move those together by the commutative property of addition. So you'll have 4s squared plus 4s plus 1, then minus your 4t squared. Okay, now it looks like something you can actually work with. So, square root of 4s squared, that's 2s. Now the middle sign's positive, so you get a positive root of 1, it'll be plus 1. If you take 2 times 2s times 1, you get 4s. So this is a binomial square or a perfect square trinomial, however you want to call it. You get 2s plus 1, that quantity squared, minus 4t squared. Okay? Now we can do a u substitution. We'll let u equal 2s plus 1. So if u is 2s plus 1, we get u squared minus 4t squared. Factor these, you get the quantity of u plus 2t times the quantity of u minus 2t. Now put the value of u back in, you would get 2s plus 1 plus 2t times the quantity of 2s plus 1 minus 2t. And that would be your factorization of this expression. Would be the quantity of 2s plus 1 plus 2t, that quantity times 2s plus 1 minus 2t. So a lot of this is being able to recognize patterns and definitely make use of your commutative property. That's what it's there for. It'll help you. Alright, what do we got here? X squared minus 4y squared plus 4z squared minus 4xz. Alright, So we got x squared minus 4y squared plus 4z squared minus 4xz. Do we notice any patterns? If we look at the patterns, it looks like that negative 4y squared is the odd man out. It definitely looks like that's the odd man out. So use your commutative property of addition, keep the x squared, move that minus 4xz right here. Then you have plus 4z squared. Then you have that minus 4y squared, which is kind of the odd man out. Now, this here looks almost identical to a perfect square trinomial or a binomial square, whatever you want to call it. Because the square root of x squared, well, that's x. You have a negative sign for your middle term, so that means you need a negative root of 4z squared. Well, that'd be negative 2z. If you take 2 times x times negative 2z, you get negative 4xz. So this is, in fact, a binomial square or a perfect square trinomial, however you want to say it. You get x minus 2z, that quantity squared, minus your 4y squared. Now, do a u substitution. Let's let u equal x minus 2z. U is x minus 2z, so you get u squared minus 4y squared. Okay? Factor this, you get u plus 2y times the quantity of u minus 2y. Now just put the value of u back in, so you would get x minus 2z plus 2y. That quantity times x minus 2z plus 2y. So yes, you got x minus 2z plus 2y, that quantity times x minus 2z. That should be minus 2y, not plus 2y, but you get the idea. So there's that one. We got m squared minus 9n squared plus 9 minus 6m. Well, let's look for any patterns here. It should be obvious by now that negative 9n squared, that's the odd man out. We're going to have to rearrange this to have m squared minus your 6m plus your 9, then minus your 9n squared. By the commutative property of addition, we can move these around. Now, let's only focus on the first three terms. The square root of m, that's m. Now the middle term is negative, so you need a negative root of 9. That'd be negative 3, so you have m minus 3. 2 times m times negative 3, that's negative 6m. This is a binomial square or a perfect square trinomial, however you want to say that. So you get m minus 3, that quantity squared, minus 9n squared. Well, I would let u equal m minus 3. Go ahead and do yourself that favor. Let u equal m minus 3. So now you'll get u squared minus 9n squared. We factor this, you would get u plus 3n times the quantity of u minus 3n. And put the value of u back in, you would get m minus 3 plus 3n, that quantity times m minus 3 minus 3n. So the factorization for this should be m minus 3 plus 3n, that quantity times m minus 3 minus 3n. Alright, 6 more problems. This is where it takes a turn a bit. We have a squared plus b squared plus 2ab plus 2a plus 2b. Well, that looks very interesting. This isn't like the previous problems. That much should be abundantly clear. Well, I would use, okay, do you see that 2ab? If you put that between the a squared and b squared, which is what we're about to do, you'll have a squared plus 2ab plus b squared, right? Then we'll just still have your 2a plus 2b. If you go ahead and do that, it almost looks like another perfect square trinomial or a binomial squared. Square root of a squared, well, that's a. We have a positive sign in the middle, so a positive square root of b squared, that'd be positive b. Alright, now you have, if you take 2 times a plus b, you get 2ab. So this is a binomial square or a perfect square trinomial, however you want to say it. So you have a plus b, that quantity squared, plus 2a plus 2b. Well, it looks to be that we can factor a little further. That 2a plus 2b, they have common factor of 2. So you'll have a plus b, that quantity squared, plus you'll take your 2, factor that from your 2a plus 2b, 2 times what equals 2a? Well, that'd be b, plus you have 2 times what equals 2b? Well, that'd be b. Well, all of a sudden now we have 2 terms with a common factor of a plus b. We will let u equal the a plus b. U can be a plus b, so then you would have u squared plus 2 times u. Well, you factor out the common u times what equals u squared? That'd be u, then you just have plus 2. Well, let's put the values of u back in. U is a plus b. You would have a plus b times the quantity of a plus b plus 2. So factoring this out, you would get the quantity of a plus 2b times the quantity of a plus b plus 2. A plus b times the quantity of a plus b plus 2. I don't know where I got that 2b from, but in the end, that's what you get. It's just being able to recognize patterns and being, if you can spot perfect square trinomials or binomial squares, however you want to call it, that's going to make your life much easier. That makes your life so much easier if you're good at spotting those. And how to use your commutative property to rearrange the variable terms to be able to get a factorable result. Alright. We got 5 more, so we got p squared minus q squared minus 2p plus 2q. Alright, so we got p squared minus q squared minus 2p plus 2q. Well, it certainly doesn't look like we need to move anything around. This time we clearly don't have a perfect square trinomial, because if we were to have that, you would need a PQ term, which you don't have. So you're going to have to take this 2 terms at a time. if we look at the factors of p squared minus q squared, you would get the quantity of p plus q times the quantity of p minus q, right? That's the factorization of p minus q squared. That much we've done now. Now you have negative 2p plus 2q. You can factor out a negative 2. So you have minus 2. Now negative 2 times what equals negative 2p? Well, that'd be p. Negative 2 times what equals positive 2q? That'd be negative q. So now you have here the quantity of p plus q times the quantity of p minus q, minus 2 times the quantity of p minus q. So I would, if I were you, let u equal p minus q. Let u equal p minus q. So you would end up getting u times the quantity of p plus q minus 2u. Well, if you factor out your common u, you'll get u times the quantity of p plus q minus 2, right? Now you just put the value of u back in. You would get the quantity of p minus q times the quantity of p plus q minus 2. And that would be your factorization for this expression, would be p minus q times the quantity of p plus q minus 2. So really not too terrible. Alright, we got like 4 more, then we're done. Just hang in there a little bit longer. We got x to the 4th, minus y to the 4th, minus 4x squared plus 4. Well, we don't have any perfect square trinomials here because we need an xy term in order to have that. So we don't have that. So this looks like another one you're going to take it 2 terms at a time. You got x to the 4th minus y to the 4th. Focus only on that for the time being. X to the 4th minus y to the 4th, those are a difference of 2 squares. You get x squared plus y squared, that quantity, times x squared minus y squared. So far we factored that. Now you can do, between the negative 4x squared and 4, you could factor out a negative 4. You'd have minus 4. Now negative 4 times what equals x squared? Well, that'd just be x squared. Then negative 4 times what equals positive 4? Well, that'd be negative 1. Okay, well, what we have here now you know what? I just realized I put it in the wrong order. Mistakes can be made. That's okay. That's okay. Sometimes you'll do that. Sometimes it's trial and error. You'll see it doesn't work how you were thinking. It's good to pay attention to this. If x to the 4th minus y to the 4th minus 4x squared plus 4. Well, this, we do have a perfect square trinomial. I'm going to show you how in just a second. I will show you how in just a second. If you look at x to the 4th minus 4x squared plus 4, it looks like your y to the 4th is the odd man out. So you can rearrange this by the commutative property of addition. You would get x to the 4th minus your 4x squared plus 4, do that minus y to the 4th. Now, it looks like we have a perfect square trinomial here for your first three terms, or I would say a binomial square, however you want to say it. Square root of x to the 4th, that's going to be x to the 2nd. Now, you have a negative sign for your middle, so you need a negative root of 4. Well, that would be negative 2. If you take 2 times negative 2 times x squared, you get negative 4x squared. So that, in fact, does check out. That would check out. So you have the quantity of x to the 2nd minus 2, that quantity squared, minus your y to the 4th. Well, what you want to do now, I would do a u substitution. Let your u equal x to the 2nd minus 2. So you would get u squared minus y to the 4th. Alright, so if we do the factorization of a difference of two squares, you get u plus y to the 2nd times the quantity of u minus y to the 2nd. So what you're going to have now, put in the value of u, you would get x squared, the quantity of x squared minus 2 plus y squared, that quantity times the quantity of x squared minus 2 minus y squared. Okay. And really, that's going to be about all you can do for the factorization. So the quantity you should get is x squared minus 2 plus y squared times the quantity of x squared minus 2 minus y squared. So yes, even I make mistakes sometimes. I'm not above that. I didn't say I was perfect, but sometimes that's how you learn it too. You gotta look at the pattern. We have a to the 4th plus b to the 4th minus c to the 4th plus 2a squared b squared. Well, if we look at the pattern here, we do have an a squared b squared term. It looks like we can actually have another perfect square trinomial, or a binomial square, whatever you want to say. It looks like your c to the 4th is the odd man out. So rearrange this, you'll get a to the 4th plus 2a squared b squared plus b to the 4th, all that minus the c to the 4th. Now it looks like we got a perfect square trinomial, something we can work with. Alright, square root of a to the 4th, well, that's a squared. The square root of, since we have a positive for the middle term, we need a positive square root of b to the 4th, well, that'd be b squared. And if you take 2 times a squared times b squared, you get 2a squared b squared. So yes, this was a perfect square trinomial. You get a squared plus b squared, that quantity to the 2nd power minus c to the 4th. Well, I would again let u equal a squared plus b squared. Go ahead and do that. You would end up getting u squared minus c to the 4th. So now, if you take the factorization of this difference of two squares, you would get u plus c squared that quantity times u minus c squared. Now put the values of u in, you would get the quantity of a squared plus b squared plus c squared. That quantity times a squared plus b squared minus c squared. So yes, you got a squared plus b squared plus c squared. That quantity times a squared plus b squared minus c squared. Two more problems, folks, and we're done. Thank you, everybody, for your patience. Thank you, everybody, for watching. All right. We got p squared plus q squared minus r squared minus 2pq plus 2r minus 1. Yeah, we got a doozy. Yeah, we have a doozy here. Okay. Well, notice we have a PQ term. It would almost appear again that you can, by the commutative property, you can go ahead and rearrange this in such a way that you have a difference, that you'll have a perfect square trinomial. If you'll take p squared minus 2pq plus q squared, alright, and then group your r's together, it looks like you're almost going to have another binomial square or perfect square trinomial. You'll have minus r squared plus 2r minus 1. It looks now like we have two sets of perfect square trinomials. Right? So, let's do the first three terms first. Square root of p squared, well, that's p. Now, you have a negative sign in the middle, which means you need a negative root of q squared. Well, that'd be negative q. If you take 2 times p times negative q, you get negative 2pq. So this is, in fact, p minus q squared. We've dealt with the first three terms. Now, with your negative r squared plus 2r minus 1, we can factor out a negative 1. Negative 1 times what equals r squared? That'd be positive r squared. Negative 1 times what equals positive 2r? Well, that'd be negative 2r. Then negative 1 times what equals negative 1? That'd be positive 1. Well, what do you know? You have here another perfect square binomial, or perfect square trinomial rather, or binomial square. Because we'll keep your p minus q, that quantity, squared, minus, then you have the square root of r, well, that's r. You have a negative sign for your middle term, so you need a negative root of positive 1. That'd be negative 1. If you take 2 times r times negative 1, you get negative 2r. So now you have a difference of squares. You have p minus q, that quantity squared, minus the quantity of r minus 1 squared. Now do a couple substitutions here. Let u equal p minus q. Let v equal r minus 1. So p minus q, we decide that was u. That'd be u squared minus the r minus 1, that's v squared. So we have u squared minus v squared. Now you're simply just going to take a difference of two squares. You would get u plus v, that quantity, times u minus v. Now it's time to put your values back in for the u and v. For u, it's p minus q plus your v, so that'd be plus r minus 1. that quantity times the quantity of u, well, u rather, was p minus q minus r, negative negative 1, that's plus 1. So the factorization for this problem would be the quantity of p minus q plus r minus 1 times the quantity of p minus q minus r plus 1. And I got one more problem, folks, then we're done. Thank you for hanging on. H squared minus 4k squared plus 4h minus 8k. So we have h squared minus 4k squared plus 4h minus 8k. Well, we don't have an hk term, so we don't have a perfect square trinomial. It looks to be that we're going to have to take this two terms at a time. So let's just worry about factoring h squared minus 4k squared. The difference of two squares, you would get h plus 2k times the quantity of h minus 2k. Now, we factored the first two terms. We have between 4h and 8k, we have a positive 4 we can factor out. So we have 4 times what equals 4h? Well, that'd just be h minus 4 times what equals 8k? Well, that'd be 2k. Well, what do you know? We have two terms now with a common factor of h minus 2k. Well, let's go ahead and factor out your common h minus 2k. If you do that, you have the quantity left over of h plus 2k, then you just have the plus 4. So the factorization of this is going to be the quantity of h minus 2k times the quantity of h plus 2k plus 4. So that's been it by factoring by grouping. The next lesson we will start solving quadratic equations that involve factoring. So I hope everybody has a good night. Take care.